So mass is going to be the third measurement that we're going to talk about in our series here on measurement systems. And we're going to start right off with a distinction between imperial and metric measurements. Over here on the left side, I have the standard imperial measurements. Those are ounces, pounds, and tons. And over here on the right side, I have the metric unit. That would be grams. All right, so I'm going to just grab a quick question here. How many ounces are there in 3.5 pounds? Well, again, this is all about unit analysis, right? I have 3.5 pounds, the abbreviation for pounds, and I want to go to ounces. So I have to have ounces on the top and pounds on the bottom. Well, my conversion over here tells me that there are 16 ounces in 1 pound. Right, so the pounds cancel. Now you get out your calculator. 3.5 times 16 is 56 ounces. Nothing new here, right? Nothing new. We're using the exact same processes that we've used in all of our other conversions. Okay, now I do have to stop for just a minute because I know anybody who's taken a physics class probably cringed a little bit on that last slide. But we need to make a distinction between mass and weight, right? Mass, it is a physical property. The mass of an object doesn't change no matter where it is. Weight, on the other hand, does change. Weight is dependent on gravity. So, for example, my weight here on Earth is one thing. My weight on the moon, where the gravity is 1/6 of what it is here on the Earth, is going to be different. It's going to be less. Right? So it's an important distinction. Now, as long as we kind of stay right here on the Earth's surface, it's not uncommon for people to kind of politely pretend that they're the same, right? Even though they really aren't. Okay, so again, now referring back to our units, the gram is a measurement of mass, right? Not weight. The number of grams in an object is going to stay the same no matter where it is. Pounds, and by extension ounces and tons, those are the imperial system's measurements for weight. Okay, it's not a distinction we're going to make a big deal out of here. It's not something you're going to really be concerned of outside of a science or engineering or physics class. Okay, but you should be aware that there is a difference. Okay, so water is a little bit special, right? Especially when we're talking about metric measurements, right? 1 cubic centimeter of water is equal to 1 milliliter. We saw that's true for everything, right? We saw that in the last lecture when we're talking about measurements of volume. When we're talking about water, 1 milliliter of water is also equal to 1 gram of water. Right, now also at the end of the last lecture, we saw that 1,000 cubic centimeters is equal to 1 liter. Right, well, if I multiplied everything on the first row by 1,000, you multiply a gram by 1,000, you get 1,000 grams. 1,000 grams is a kilogram. Right, so again, milliliters to grams, liters to kilograms. All right, now, so I got an example here, right? A recipe calls for 120 milliliters of water. You don't have a graduated cylinder handy. You do, however, have a scale. You want to know how much weight that is, how much mass that is. Well, we could just use our conversion factors here. 120 milliliters, right? I want to go get rid of the milliliters and be left with grams. So I'm looking up here. You see, this is nice. It's 1-to-1. 1 gram is 1 milliliter. The milliliters cancel, and you're left with 120 grams. Okay, how about going back and forth, right, between imperial and metric units? And again, like I said earlier, there's kind of an implicit assumption here that you're doing this kind of on the surface of the Earth, right? If you go out into outer space or something crazy, then these numbers will be different. But here on Earth, 1 ounce is 28 grams. 1 pound is 0.45 kilograms. So, again, let's run through a quick example. How many kilograms are there in 1 ton? Right. Well, I don't have a conversion from tons to kilograms, but I do remember from our previous lecture, 1 ton is equal to 2,000 pounds. Okay, so now I can do what we've done before. I'm going to go from tons to pounds, then I'll go from pounds to kilograms, and I'll have my answer. Right, so 1 ton times 2,000 pounds per ton times, now I'm going to actually hit the metric unit. 0.45 kilograms per pound. The tons cancel, the pounds cancel. All that's left is kilograms. That's what I was aiming for. Now you go to your calculator. 2,000 times 0.45 is 900. 900 kilograms. There's my answer. Okay, so what's next? We've got one more topic. All right, one more thing we've got to talk about. We're going to take a look at temperature. And again, there's going to be kind of an imperial system, that system's version of measurement versus the metric system's version of measurement.